How do you calculate arc length in a circle? Imagine you're walking along the edge of a circular track. How far have you gone if you only walk part of the way? That's where calculating the arc length comes in. When you want to find out the length of just a part of the circle's edge, you need two key pieces of information. First, the radius of the circle, which is the distance from the center to any point on the edge. Second, the central angle, which is the angle formed at the center of the circle by the two radii that connect to the endpoints of the arc. The arc length is basically the part of the circle's total circumference that corresponds to that angle. If the central angle is measured in degrees, you can find the arc length by taking the fraction of the circle that the angle represents and multiplying it by the total circumference. The formula for this is to take the angle in degrees, divide it by 360, and then multiply that by 2 times pi times the radius. So, if the angle is 60 degrees and the radius is 5 centimeters, you would do 60 divided by 360, which is 1/6, then multiply that by the full circumference of 10 pi centimeters. That gives you approximately 5.20 centimeters for the arc length. If the central angle is given in radians, the calculation becomes even simpler. Since a full circle is 2 pi radians, the arc length is just the radius multiplied by the angle in radians. So, if the same 60 degrees is converted to pi divided by 3 radians, you multiply the radius of centimeters by pi divided by 3, which again gives about 5.20 centimeters. This way of calculating makes it easy to connect the length of the arc directly to the size of the angle and the radius. It's especially helpful when working with sectors of a circle, because knowing the arc length helps you find the area of that sector. The sector area is proportional to the central angle, just like the arc length. So, understanding how to find the arc length is a key step in understanding the properties of circles and their parts. Whether you're measuring a slice of pizza or a section of a circular track, these formulas help you get the exact distance along the curve.